The Sun is the centre of the solar system. It is made of hot hydrogen and helium in a plasma form, amongst traces of heavier elements. Its mass is 1 solar mass, or 1.989 by 10 to the 30 kilograms. It's formed about 4.5 billion years ago. Its surface temperature is 5,778 Kelvin. It is 150 million kilometers from the Earth. This distance is also known as an astronomical unit. The Sun has a magnetic field, which changes direction every 11 years. The Sun is a main sequence star, thus generating its energy by nuclear fusion of hydrogen nuclei into helium. In its core, the Sun fuses about 630 million metric tons of hydrogen each second. It orbits the center of the Milky Way at a distance of approximately 24,000 to 26,000 light-years from the galactic center. The Sun is a magnetically active star. The field leads to many effects that are collectively called solar activity. This includes sunspots, solar flares, and variations in solar wind. The solar affects Earth with auroras at moderate to high latitudes, disruption of radio communications, and electric power.
Stars differ from each other in radius, mass, density, temperature, color, and luminosity. Luminosity is the amount of energy emitted by a star per unit of time. The SI unit for it is watts. The energy emitted includes all wavelengths of the electromagnetic spectrum. Our Sun, for instance, has an output of 3.846 times 10 to the 12 watts. Luminosity is also a measure in bolometric magnitude, also known as absolute magnitude. Solar radius is fairly self-explanatory. A star's diameter can be measured through the use of trigonometry. Mass and density of a star. Mass is measured in solar masses. 1 solar mass is the mass of our Sun. 1 solar mass is equal to 1.98191 times 10 to the 30 kilograms. Stars vary greatly in density. Excluding black holes, neutron stars are the most dense. They are dense because they are solely composed of neutrons that are very, very tightly packed together. Stars' colours range from red, orange, yellow, blue, gold, and white. They also emit rays that aren't of the visible spectrum. The larger the star is, the hotter it will be because of the intense gravitational pull, making its fuel burn faster. This means that large stars will have shorter lives. Large stars can live for less than 1 million years, while small stars can live for billions and billions of years, trillions hypothetically. The temperature of a star determines its colour.
Stars use nuclear fusion as their energy source. Because of their immense gravitational pull, there is enough pressure and heat in their cores to fuse 2 atomic nuclei together. 3 types occur: proton-to-proton fusion, helium fusion, and the carbon cycle. Proton-to-proton fusion occurs when the 2 particles fuse together. One transmute into a neutron, forming the hydrogen isotope of deuterium. Deuterium fuses with another proton. 2 of the following helium nuclei fuse to form an alpha particle, and the 2 protons are released. Helium fusion, also known as the triple alpha process, is where 3 helium atoms fuse to form carbon-12. The carbon cycle involves a lengthy decay and transmutation cycle. The particles released in these reactions decays are the energy that is released. The protons released is the light that we see.
The properties of stars can be measured on a Hertzsprung-Russell diagram. A Hertzsprung-Russell diagram plots a star's brightness or absolute magnitude against their colour. From this, the temperature and the size can also be determined. The hottest and brightest stars are blue and the largest, while the cool, dim red stars are the smallest. The main sequence stars follow a fairly linear pattern. Triangulation is the main method of measuring the distance to a star. It involves measuring the angle the Earth makes with the star every 6 months. Using the 2 angles and the diameter of the Earth's orbit, the sine rule can be applied and the distance measured. Stars that are less than 400 light years away can also have their distance measured using their brightness.
The Doppler effect is a change in frequency of a wave, or other periodic event, for an observer moving relative to its source. Compared to the emitted frequency, the received frequency is higher during the approach, identical at the instant of passing by, and lower during their recession. When the source of the waves is moving towards the observer, each successive wave crest is emitted from a position closer to the observer than the previous wave. Each wave takes slightly less time to reach the observer than the previous wave. It was confirmed in 1846 that the sound pitch was higher than the emitted frequency when the sound source approaches the observer, and lower than the emitted frequency when the sound source receded from him. Hubble's law. is the observation in the physical cosmology that objects observed in deep space, 10 megaparsecs or more, and found to have a Doppler shift interpretable as relative velocity away from the Earth, and that this Doppler shift measured velocity of various galaxies receding from the Earth is approximately proportional to their distance from the Earth for galaxies up to a few hundred megaparsecs away. This is normally interpreted as a direct physical observation of the expansion of the spatial volume of the observable universe.
Astronomers are still not sure how galaxies form. One theory is that they formed around protostars soon after the Big Bang. They would have merged and spread out as the universe expanded. Stars and planets form together, hence why we have a solar system. Because of gravity, one larger speck of dust will attract the smaller ones. If this effect happens over millions of years, that one original speck of dust will have grown and grown, become hotter and hotter until it was a hot spinning ball of matter. This early star sheds off its heavier elements off itself, leaving just light gases like hydrogen and helium. When these light gases start to fuse their nuclei, the gas becomes a star. The heavier elements that the ball of gas shed go through the same process again. Bigger chunks of rock and gas attract and smash into each other. Heavier elements form planets closer to the star, and gases are flung further away. Rocky planets start off as a spinning ball of molten rock. As it cools, rocks form. The rest is history. The molten center of the Earth is a remnant of the molten state the surface once was.
The Milky Way galaxy is our galaxy. It contains our solar system, which contains our Earth and us. The name Milky is derived from its appearance as a dim glowing band arcing across the sky at night, but with the naked eye you cannot distinguish individual stars. It appears like a band of its disc-shaped structure is being viewed from within the galaxy. The Milky Way is a barred spiral galaxy. It is 100,000 to 120,000 light years in diameter. It contains 100 to 400 billion stars. Our solar system is located within the disk, about 27,000 light years away from the galactic center, on the inner edge of a spiral-shaped concentration of gas and dust called the Orion Arm. The galactic center is marked by an intense radio source named Sagittarius A, which is likely and theorized to be a supermassive black hole. Stars and gases at a wide range of distances from the galactic center orbit at around 220 kilometers per second. The Milky Way as a whole is moving at a velocity of approximately 600 kilometers per second. Our older known stars are around 13.6 billion years old. Other types of galaxies include ellipticals. They have relatively little interstellar mass, a low proportion of open clusters, reduced rate of new star formation, and they are dominated generally by older, more evolved stars. They are the largest galaxies. There are also spirals and barred galaxies. Their visible stars are spiraling in a pinwheel shape. Other types of galaxies, which are quite peculiar, include ring galaxies, which possess a ring-like structure of stars and interstellar medium surrounding a bare core, lenticular galaxies, a mediate form that has properties of both elliptical and spiral galaxies, and dwarfs, which are relatively small when compared to most galactic formations, being around only 1/100th of the size of the Milky Way and containing only a few billion stars. The steady-state theory is now obsolete. It states that new matter is continuously created as the universe expands, thus adhering to the perfect cosmological principle. It was popular around the first half of the 20th century. It was first idolized by Sir James Jeans in 1920, based upon the hypothesized continuous creation of matter in the universe. Steady state asserts that although the universe is expanding, it nevertheless does not change its appearance over time. It has no beginning and no end. This steady state was pushed away at the discovery of the cosmic microwave background radiation. The Big Bang theory, which is now the most likely theory of the creation of the universe, states that the universe is constantly expanding. The universe was denser and hotter in the past, starting from a single point of matter, also known as the singularity. Modern measurements place this moment at about approximately 13.82 billion years ago. The singularity was a super-dense, superheated point theorized to have exploded, causing the initial explosion. As the universe expanded, it slowed and cooled, eventually sufficiently to allow the formation of subatomic particles, including protons, neutrons, and electrons. The majority of atoms produced by the Big Bang were hydrogen, although helium and traces of lithium were also in explosion. Giant clouds of these primordial elements later coalesced through the galaxies to form stars and the heavier elements were synthesized either within stars or during supernova. It does not provide any explanation for the initial conditions of the universe, rather it describes and explains the general evolution of the universe going forward from that point on. General relativity describes space-time by being a metric, which determines the distances that separate nearby points. The points which can be other galaxies, stars, or other objects themselves, are specified on a coordinate chart or grid, is laid down over all space-time. The Big Bang is not an explosion of matter moving outwards to fill an empty universe. Instead, space itself expands with time everywhere and increases the physical distance between two co-moving points. In 1964, Arno Penzias and Robert Wilson surreptitiously discovered the cosmic background radiation, an omnidirectional signal in the microwave of a band. The radiation was found to be consistent with an almost perfect black body spectrum of all directions. The spectrum has been redshifted by the expansion of the universe. Redshift happens when light or other electromagnetic radiation from an object is increased in wavelength or is shifted to the red end of the electromagnetic spectrum. And when the radiation grows redder, it means that it is an increase in wavelength, equivalent to a lower frequency and a lower photon energy, in accordance with the wave and quantum theories of light.
The Big Bang theory is the most widely accepted theory because of the background radiation and redshift that supports it. The background radiation is actually the remnant of superheated fast-moving plasma from the explosion that was the Big Bang. The redshift observed in celestial objects proves that they are indeed moving away from us. The steady-state theory is discredited because it does not abide by the law of conservation of matter. It states that new matter is created out of nothing. Interpreting data. On the Hertzsprung-Russell diagram, the star with the highest surface temperature is star D, as spectral type corresponds with heat. A blue colour represents a higher temperature. Which star on the diagram is a supergiant? Why? Star A is a supergiant because it is the largest star on the diagram. The group of stars that the Sun belongs to is the main sequence stars, where there is a fairly linear relationship between size and heat. The Sun will most likely evolve into a red giant as it gets older. Star A has the greatest absolute magnitude out of all the stars in the above diagram.